Alrighty. Hi, everyone. Hope we're doing well today. Let's see. I'll change my name to be myself for a minute. Cool. So yeah, we're back and we're talking about Jai again today, which I'm pretty excited about. So yeah, for those who were not here last time, basically I'll give a quick recap. If I can get my voice to cooperate. Yeah, so Jai is this programming language. It's a newish language. It's not really publicly available yet, but I'm part of this little beta program that can use it. And basically, it's meant to be a little bit like C, a little different than C++, a little different than Rust and some of these other newer languages that are maybe trying to replace C++. But yeah, it's meant to be very high performance, hopefully very easy to use, and give the user a lot of low-level control over whatever they might want to do with their program or with their code. And so yeah, for those reasons, I'm kind of excited about it as maybe a language that we could use for some audio programming purposes. But at the same time, it's not really designed to be used for audio programming. It's designed to be used for game programming. So there's some differences there that, could cause issues. But yeah, I've been trying it out. I've been excited about, just being able to mess around with it and see what works and what doesn't, and what maybe I could borrow to use in my C++ code, or things that maybe aren't currently possible in C++, but maybe someday down the line that would be a cool thing to have. And yeah, so as an example, I've been making this little state variable filter plugin. It's very simple. It has no UI, and it has just these two parameters, cutoff and filter queue. And yeah, we can see here that it works as expected with the EQ curve analyzer. We can see that the parameters do what we expect them to do. So yeah, that's kind of where we got to last time I was talking about Jai. And today I wanted to delve into a few more things that are kind of unique to the Jai programming language and what you can do with it. And yeah, there's a couple of things that I'm particularly excited about that I'm hoping to get into. So that should be a fun time. First, I'm going to make my screen zoom level a little bit different here, just so hopefully it's easier to see for everyone. Yeah, maybe that's a little better, since I know it can be quite small otherwise. Yeah, all right, so here we go. So this is VS Code, and I've got it set up with my little Jai project here. Last time I was doing this, I was actually working on Windows, because at the time the Jai compiler was Linux and Windows only. The most recent update to the compiler added macOS support, or added back macOS support. I think it was supported sometime earlier. And so yeah, I'm working on my Mac today, and we'll see if maybe there's any differences or any things that the compiler doesn't do so well in Mac world, but I think it'll be fine. One thing I did have to do, though, is change my build script a little bit. So on Windows, basically all I had to do is rename the DLL file that the compiler generated for me, rename it to a clap file. Easy enough. On Mac, I had to do a few extra steps. So on Mac, they use this kind of bundle format for audio plugins and for many other things. So basically, I had to make this little bundle here manually, and then copy the dynamic library in there. Eventually, it would be really nice to be able to automatically generate this stuff for me, but yeah, I haven't fully figured out how to do some of that stuff yet. And there's things that I think are more interesting to work on. So maybe I'll do that for today. Oh, cool. Jamie's watching. Hey, Jamie. Yeah, so the main thing I wanted to talk about today is this concept in Jive, what they call a context. And I'm pretty excited about this because I think it opens up a lot of interesting opportunities for things that we can do with our DSP code. In particular, things that you may want to do in C++, but may not be real-time safe. I think the context opens up a lot of interesting opportunities for doing that. And so I'll kind of show you what I'm talking about here. So let's see, I may have to go kind of down a level. Yeah, so first I'll show you guys a little bit of the clap bindings that we have going on. So this is basically code that's supposed to interface between what the clap plugin format expects and what I want to do with my plugin. And you might notice this thing here where I say push context, and then I give it this context. The reason why I have to do that is because this function is marked as a C call, which means that it can be called using the C calling conventions. And this is necessary for doing things in clap world because clap is kind of C based. And so I need everything to interoperate correctly with C. But then once I'm inside this function, I kind of want to do things in sort of a Jai format or use the Jai workflow for this kind of thing. So I'm going to create a context. And that's going to be the context that will be used for everything else that happens inside this function. And if you look through this code, there's push context in a bunch of other places here. So yeah, you might be saying, okay, well, what the heck's a context? Let's find out. So let's see if I can find it here. It's probably in the basic modules. These are a bunch of modules that come with the compiler. I think context lives somewhere in basic, maybe. Or maybe it's even earlier. Yeah, it might be in preload here. Yeah, here we go. So here's a context base. So every context that we might use has this context as its base. And basically, the way a context is intended to work is that you have one per thread. So you have a thread index, so that allows it to kind of work sort of in like a thread local way, like you would do in C++. You'd say, oh, I want this to be thread local. Then you've got a couple of interesting things here. So we've got an allocator, we've got a logger, we've got some other things related to the logger, and then we've got this thing called temporary storage. And then we've got some other things here that I'm not as familiar with. I guess stack trace is in case you want to print out the stack trace of your program. And you've got some other stuff for handling assertions. Yeah, and those are all useful for various things. But today I mainly wanted to talk about the allocator and temporary storage because I think those provide some interesting patterns that can be really useful for audio programming and developing audio applications. Specifically, the allocator is really, really important. And the reason why it's so important is because basically, so I'll make a new file here, and we'll make it a C++ file, just because. So let's say in C++ we have some audio processing function, right? And we want to do something that uses effectively dynamic memory where, we need, let's say, maybe this is int num samples, and num samples is provided by, maybe it's provided by the DOS since we're in a plugin. or by the, the audio callback somewhere further along. So we don't know what num samples is at compile time, but now we need some array of floats, and we need it to be num samples large. Okay, great. So in C and with some C++ compilers, you can do this with a variable length array, and that's fine. Well, it's sort of fine. So this is like not always supported. And then you can do whatever you want with the array. And then the one thing you cannot do, cannot return the array, right? And the reason why you can't return it is because the array is a stack variable here. So that's created using stack memory. And when you get to this closing brace, that memory kind of goes away. And so you can't use it outside of the scope of this function. And so you might look at that and say, well, that's stupid. Why don't we just use standard vector, right? Standard vector. And we'll call this, I don't know, vector, right? And now this restriction goes away, right? We can return the vector or do stuff with it outside the scope of this function. And we know that's fine so long as we, follow the correct way of moving the vector so that it doesn't get deleted at the end of the scope. The problem is that this is not real-time safe because vector allocates memory. And yeah, so that's a big problem with using vector. Now, Timur Jumler gave a talk kind of about this at ADC a couple of years ago. And well, he touched on this. It was more broadly, it was a talk about using the C++ standard library in audio programming. And basically, the solution that he came up with was to use a polymorphic allocator. And that's kind of this thing that's newish in the standard library, standard PMR. PMR, I think, stands for polymorphic resource. I don't remember exactly. But the idea is that you could define your own allocator and then create a vector using, standard PMR vector, right? So maybe instead you want to use standard PMR vector float, right? So this you can do, right? And this is real-time safe if the allocator is real-time safe, right? So that kind of gives us a way to use vector in real-time code. And that's fine, we can do that. It takes a little bit of extra effort to set up, but not, it's not so bad that it would be really painful to do. Now, the problem that we run into with trying to do this kind of thing in C++ is what happens if, what if this function is provided by some external or some, let's say, third-party library, right? And specifically, what if that library doesn't know that we're trying to use it in a real-time safe context, right? So maybe they could have some template here for the allocator that we want to use, right? But like realistically, most third-party libraries wouldn't do that. They would just use standard vector and be done with it. And that's a bit of a problem in writing audio code because it really limits the third-party libraries that we could use, right? We may want to use a third-party library, but we can't because it uses things like standard vector, and we can't use standard vector without losing our real-time safety. So yeah, that's a problem. Now in Jai, we have things that work a little bit different. So maybe I'll change this file to be a Jai file. So we'll say I have my function, right? And it has num samples or something like that. Did I get my syntax correct? I think I did. Oh, come on. So yeah, now we're in our Jai function, right? And this is, again, some audio process, right? And so in Jai, we have we still have dynamic or resizable arrays, right? It's if I can remember how to do it. It's a new language. I'm still getting the hang of it. So yeah, it's gonna take me some time to remember some things every now and then. But yeah, so we have a resizable array, kind of like this. So this is basically the equivalent of standard vector, right? So we would have a vector of floats, right? And we would do, maybe something like this to, add a number to it. This would basically be like pushback, right? This is like push back essentially, right? And so if you do this in kind of just a standard Jai program, this will also allocate memory and this won't be real-time safe. However, so again, let's say that this is some third party code, right? And now this is my code. So I'll call this my func. And again, we have num samples, something like that. Right. Basically, what I can do here, if I already have some allocator lying around, I can take the context and change the allocator to be my allocator. Right. And then I can call audio process like that. Right. And so the trick here is that this uses whatever allocator is in context.allocator, right? And so the benefit here is that you can use third-party libraries, and even if they do things like dynamic memory allocation, you can control what allocator they're using by just changing the allocator field in the context. And so this kind of gives you a lot of freedom in the sense of what you might want to do with Jai. So as an example, I'm going to create a very simple gain processor using kind of a smooth gain kind of thing, like you might find in Juice. And I'm going to use this kind of allocation to basically dynamically allocate memory in a way that is real-time safe, using the Jai allocator, context allocator mechanisms. So that's my plan for today. We'll see how far I get. Like I said, I'm still very new to this language, so things tend to go a little slowly for me, but yeah, I don't think it'll be too terribly bad. So I'll make a new file here called DSP gain. And yeah, let's see what we can do here. All right, let me pull up some old code so I can maybe remember how I did some things. All right, yeah, actually, as I start on that, if anyone has any questions about what the heck is this context thing you're talking about, how does it work? how do you make a real-time safe allocator, anything like that, I'd be happy to talk about it if people are curious. All right, so I'm just setting up some dependencies here, and I'll make my gain. I'm going to call it. I'm going to call it smoothed gain, just to be a little bit extra clear. Should I make it polymorphic? Yes, I should. So this is basically what a template is in C++. So basically, I want this to work. I want the smooth gain to work generically for any type. So I'm going to put this sample type as like in C++, we call it a template argument. In Jai, they call it like a polymorphic argument or something like that. But here, yeah, here we'll just call it a polymorphic argument. And we'll say that it's a type and it will be sample type. So legitimately, we might want it to be probably a double or a float or something like that. And so all we need to store here is current gain. And this will be a sample type. And target gain. This will also be a sample type. I guess we may need a couple of other things. So we need the smoothing time, right? Because we want some kind of like a ramp thing for our smoothing. So let's see. This is parameter stuff. And so now we want something for smoothing. So we want to know the smoothing increment. This could be a sample type. And we want to know smoothing countdown. This could be a U32 maybe. And yeah, I'll put some default values in here. Let's see. So smoothing time, what units should I do the smoothing time in? I'll do it in samples. This should be a U32 then. And then we also need the sample rate for that to work. And this should be a type sample type. And I'll do 4800 just as a default. Yeah, I think that's all the information that we need to get the smoothing working. So you might notice that in a C++ version, we might also want some data to use, some data to use for the smoothing. So this would be like smoothing data, and this would be a array of sample type, right? But in Jai, we don't need this, right? And so, yeah, I mean, this is a bit of a toy example because like we have a solution for this in C++, and it's not a bad solution. But the trick here is to kind of, the idea here is just to kind of show something that you can do in Jai. And then, you know, maybe I'm sure folks have other ideas of how they can use it in, you know, more complicated situations or situations where it solves a more meaningful problem, you know. All right, so let's make a prepare method. So this will be using, so it's basically like in C++, what we would call a member function. And so it's a smooth gain, and we need to give it the template argument. We'll call it T. We want our sample rate to be of type T. And then we also want some initial value. How about yeah, I think that should be fine. So let's set the current gain equal to the initial value, and do the same for the target gain. And then let's do this. We'll say smoothing increment equals 0. Smoothing countdown should also equal 0. Smoothing time samples. Well, let's think about this. So, you know what? I'm going to add some more arguments here. We'll say smoothing time seconds should also be an argument. So I'll say sample rate equals fs, and then smoothing time samples should be smoothing time seconds times fs, right? And then we need to cast this to an int, don't we? Cast, I think I can do it like that. Might be getting that wrong. We'll find out. Yeah, actually, let's try compiling this and seeing what happens. So here we go. Yeah, let's do this a compile, see where we get. Oh, missed a semicolon. Yep. Usual suspects. There we go. Seems like everything is fine for now. Well, actually, let's see if we can get the gain going here. So gain is dot smooth gain, and we'll do float 32. And then yeah, let's see if that compiles. That's fine. So then we can do a prepare as well. So we'll do gain dot prepare gain. We'll need our sample rate again. We'll say the initial value for our gain should be 0, and then we'll say the smoothing time should be, let's do something slow for now. So we'll say 1 second. That'll make it very apparent what's going on. Yeah, that seems fine. Let's see if that compiles. It does not. What's our problem? Type mismatch, wanted U32 given float 32. Oh, I think I messed up my parentheses here. So yeah, Jai is definitely a bit stricter about casting between types than C++ is. And I guess that's either a good thing or a bad thing, depending on your opinions about how C++ does it. You know, I don't mind it either way. I think I'm not too opinionated. So yeah, now let's do this. Let's have a process method. And this will also be using, and we'll need a buffer. So how did I do the buffer for the SVF? Oh, I did process sample. Okay, maybe I don't want to do it that way for this one. Okay, I had it like that. I don't know where this gets imported from, but maybe it's all right. We'll find out. Yeah, so we're going to process a whole buffer. And then we're also going to have a new target, which will be of type T. Right. So let's update some things here. So target gain will equal new target. Let's see. So if target gain is not equal to current gain, then we'll say smoothing countdown equals smoothing times samples. And we'll say smoothing increment equals, it should be the difference, right? So it should be target minus current divided by, we're going to cast this the smoothing countdown, right? All right, so that's our smoother. So now we need some data. So we'll say smooth gain data is a array, a dynamic array of t's, right? And then we'll want to do this array resize here. So this is where in the past, this would have been like a dynamic allocation, but here we can do it without a dynamic allocation, although we do need to double check that everything is set up for that to happen correctly. So that'll be one of the next things we're going to do. So I'll make a to-do check that the allocator is correct here. Cool. Yeah, now we can just do some basic stuff. So let's do this. So we'll say if smoothing countdown equals 0, we also might want to have a smooth index, which will be I don't know, U32, I guess. And this will start at 0. So we'll do this. We'll say while smoothing countdown is greater than 0, we'll do how do we want to do this? We'll say current gain plus equals smoothing increment. And we'll do smooth gain data. Well, actually, we need to have another check here, and smooth data index is less than buffer samples. Yeah, make sure we don't overwrite either one. So we'll say smooth gain data equals current gain, and then we'll increment current gain. And then we'll also need to increment smooth. Oh, I didn't do this right, did I? We need that to be in there, and this will be plus equals 1. So I think that should work okay. And then here, if smoothing countdown equals 0, we'll want to do like we'll want to fill basically the rest of smooth data index. I'm just going to use a for loop. There might be like some equivalent of like a standard library function, but for now I'm just going to do it this way. So for n starts at smooth data index and goes to num samples -1, we'll say smooth gain data equals, this will be the target gain. And I'll put a little note to myself here. Optimize me, we can optimize that later. Cool, so now all we need to do is do some multiplication across our buffers. So let's do that here. Channel data in, channel data out. We'll just do channel data in times smooth gain data at the same index. And I think that should be about right. Cool, yeah, so let's see if we can get this working in here. So I'll do, well, I guess first we need a parameter, don't we? We don't have a parameter for this yet. So this will be the gain parameter. And let's see, we want to initialize the gain parameter. Gain param, call it drive, I guess. And then we probably want this to be in decibels, right? So we'll go from -18 to +18. And we'll put the defaults at 0. Seems reasonable. And then we need to register the param. Cool. So now when we go here, where did we get our params where did we get our params from here? Oh, it must come from this using self situation. So I'll just do all of the gain stuff first. So we'll say gain dot process. Is that what I called it? Yeah, the other thing we need to think about is our input buffer versus output buffer. That's getting a little messy at the moment. I don't know, I'll deal with that later. So smooth gain buffers and then new target. So this will be gain process gain buffers. Do I need to pass that as a pointer? I don't think so. I think that should already be a pointer. And then the new value should be something like this. Cast float 32. And get modulated value params dot gain. Yeah, and then let's not do the SVF stuff for now. just to simplify things. And let's see where all our stakes came from. So ESP, SVF. Okay, so where did process buffers come from? Must have come from somewhere. Hey George, how's it going? Let's see. Yeah, you know what? I'm not especially happy with some of this stuff at the moment. Let me maybe rewrite some things. Let's see. So let's see, where did this concept of buffers come from? Probably here, plugin process, right? Create process buffers. Seems like we're on the right track already. Yeah, here we go. All right, so we've got data in and data out. Don't know that I love how all of this works, but yeah, maybe. Maybe let's simplify things and do things in more of like a juice, more of a juice style. And just go ahead and copy the input to the output if we need to. And then we can, what do you call it? Yeah, copy the input to the output if we need to. And then we can do some in-place processing. I think that would be simpler. Yeah, it's going to kind of drive me nuts if we do it the other way. So yeah, maybe let's do that. So we've got a clamp buffer in, clamp buffer out. Oh, I'm actually already doing this trick here. So this is the trick I was talking about where we do a dynamic allocation, but it's real-time safe because we're using a custom allocator. And yeah, the allocator we're using here is temporary storage, which again, I can talk about later if folks are interested. All right, so let's see how we want to do this. Yeah, okay, I'm going to adjust this. So instead of data in and data out, we just have data. And we only have one num channel kind of thing. Not sure exactly how that's going to play with the clap situation, but I think it's all right. So let's see, data. It's like that. One channels equals max. Is that a thing? Let's see. There's a way to do this simply, but I'm forgetting it at the moment. Let's see. If X, is that it? Yeah, that's the trick. It's basically like the ternary operator in C++. So if num in channels is greater than num out channels, then we'll do num in channels, else we'll do out channels. So the idea here is that we always have the idea here is that we always have the max number of channels. Actually, you know what? I'm not sure I like this. I'm just going to do num out channels as the number of channels for now. And then if we need a situation where we have more inputs than we have outputs, then I'll deal with that at another time. It's definitely going to be a case like if you have like a sidechain compressor or something. But yeah, we can deal with that later. Actually, you know what? Yeah, I'm being silly. I should just stick with what I had before. Sorry for that little diversion. That's a better way to do things. I think this should be handled higher up, like maybe here, right? So I want to do in-place processing. So I'm going to do this. Let's say set up for in-place processing. Yeah, so that way I can always just operate on channel data out, and that'll be fine. Everyone will be happy with that. So here's what we'll do. We'll say if channel data in is not equal to channel data out, then we'll want to do a mem copy. I always forget the argument order for this. Mem copy destination source and count. Oh, and I could use mem set for that other thing. Oh, new here, but this is an idea I've never seen. This is just VS Code, but it's using this color scheme that I like called Cobalt. Cobalt. I think it's this one, or it's something close to this. Yeah, I actually don't love it, but it works for me just as far as like being able to look at the screen for a long time and not be bothered by it. So yeah, let's see. We're going to copy to channel data out from channel data in. And oh crap, where'd it go? And count should be size of float 32. Float 33, good one. And buffers dot samples. Yeah, so I don't know, maybe there's a simpler way to do this, but for now I'll just stick with it this way. Also, it would be nice if I could spell. Yeah, so now I'm just going to have one channel data, which is going to be channel data out. And that'll all work that way. Actually, well, I don't know. That just makes things overly complicated for no reason, so I'm not going to do it. But yeah, I can set it up this way for the SVF processing as well. Cool. So now our gain situation should work. Yeah, let's see if we can build this and try it. Oh, well, if we can get our parentheses to line up. What did I do wrong here? Oh, I see. Oh, still undeclared identifier. Okay. Well, then let's do it differently. So basically what we've got here is an array of float pointers. So I'll just pass that in as the buffers to this DSP block. Right, and then we'll also need the samples and the channels. So this can be channels, and this can be just plain samples, and this will be buffer channel. I think that's right. I feel like maybe I messed something up in there, but it feels okay to me. Yeah, and then let's go back here. Yeah, it's probably all right. Let's see if that works. No, gain is not a member of plugin params. That seems incorrect. Oh, gain param. Oh, and then I didn't adjust how I'm calling this. So let's see here. Whoops. Buffers dot data out. I think that should be all right. And then we'll have buffers dot channels and buffers dot samples. But I guess it should be num in channels, not num channels. Let's try that. Mismatching levels of indirection. Okay, let's see. I needed that, I guess. Oh, I see what I did wrong. This needs to be type T. Right. I think I can have a data type mismatch as well. Let's see. Yeah, here we go. How did I do this here? I guess I must have casted to a float 32 somewhere. Process sample. Doesn't seem like I did. Or maybe I am actually processing float 64s. That's weird. I feel like that should have given me the same error. That's interesting. Yeah, because channel data of n, channel data sub n should be a oh, never mind. Okay, that's fine. I just need to undo the one of the operators here. This should be ch o. I think it's that. Yeah, there we go. Okay, I just had a pointer that wasn't being dereferenced. Turns out, all right, once you do that, okay, and now let's see if we can actually try this in Bitwig. Let's see what happens. Does it crash? It does not crash. Okay, that's good news. Although it doesn't seem like it's working correctly either, because it doesn't have the new parameter that we registered. So that doesn't seem right. Let's delete what we had there before. All right, so now the plugin should not show up. Let's see, system cloud plugins. Yeah, no cloud plugin for this. And now let's bring it back. There it is. Weird, yeah, we're not seeing the new parameter, are we? In param, register params, that all seems correct. Do I need to do something else in here? Might be an error in my build script. Yes, this is the kind of the stuff you have to deal with when you're working in a brand new language that you're not that familiar with yet. It's always a little bit of an adventure. See what happens if we don't do that. Okay, that's a problem. So clearly I messed up my build script, because otherwise that dynamic library would have gone away. Yeah, there we go. All right. Yeah, I do need to improve this build script. It works well on Windows now, but the Mac OS version needs a little bit of work, which is to be expected. I mean, it is brand new. I only started messing with the Mac OS version today. Okay. Oh, I didn't reinstall the plugin. Yeah, there we go. We've got our drive parameter. There we go. Oh, and also we did not do our decibel conversion. Yeah, so let's get that fixed as well. Linear. What is it? 20 times log 10. Oh no, that's the other way around. We want to go decibels to gain. So it's going to be math dot power. How? Something like this. So 10 over 20, if I remember right. I may have my math functions wrong. Oh, wait. Do that right on the first try? Nice. That never happens. All right, let's see. Let's see now if we can get this to work. All right, so we're at 0 dB, and we see our gain smoothing happening, so that's kind of nice as well. So if I drop it, we see that our gain is moving very slowly, which is because we set the smoothing time to 1 second, which is kind of a ridiculously long smoothing time for most applications, but that's all right for us here. That's kind of what we're looking for. We want to make sure that our algorithm is working. Yeah, so there we go. That seems to work okay. And now let's bring back the filter just because. Yeah, that's kind of neat. Don't need that anymore. Yeah, so I kind of want to replace this with a mem set, but for now it's all right. Yeah, but so the thing I did want to touch on is the allocator. So here we're doing this array resize, but where are we actually allocating our memory for that resize? Also, I think there's an extra argument here. Initialize can be false. That'll make things a little bit easier. Yeah, so let's see if I can remember where I put this code. So here we go, plugin process. Let's see. Yeah, here we go. So what we're doing here, this is in our clap wrapper, right? We have this thing called an audio thread context. And let's see, where are we defining that? That gets defined here, right? And so this is this audio thread context, which, can we go to the definition? I don't think that's going to work. I don't think IntelliSense is going to work in VS Code for us here. But yeah, so the idea of the audio thread context is that we have this temporary storage that we can use. And basically, this is just a bunch of random memory. So we have 1,000 bytes, I guess. Maybe that's a little bit too small for what we're trying to do. Yeah, maybe something like, I don't know, 8192 would be better. But whatever, we have some amount of memory. And then when we initialize the audio thread context, we show everyone here that the temporary storage should point to this storage buffer data. And we have this much size for our temporary storage. And then where did it go? Oh, that was here. No. If I could get back to where I was a second ago, that would be great. Oh, here it is. Yeah. So here, basically what we're doing is we're saying, here's our audio thread context. We're going to push this context so that that is now the current context. I don't actually know if I need this dot context. That seems like it's maybe unnecessary. Let's see what happens if I get rid of it. Oops. Yeah, okay. Doesn't work that way. Yeah, but so basically we're saying when we're in our real-time processing loop, we're going to use this context as our current context, and we're going to set the allocator to be this temporary storage. So basically, whenever we have any code that uses the default allocator at that point in time, so that could be anything that uses a resizable array. Even if we wanted to make a string, we could do string creation without allocating memory. it's going to use this allocator here. Well, when I say without allocating memory, with using the custom allocator that we've set up here. So anything that we might want to do inside this push context scope, when we're inside this push context scope, we can use anything that wants to dynamically reallocate memory, and it will use this allocator, which just uses this, where did I put it? Which just uses this statically allocated storage here, this temporary storage. Then the other thing that we need to do, and actually I may have forgotten to do this. Yeah, I think I need to do this, otherwise we're going to have problems, but we can reset the temporary storage at the end of this function so that whatever memory we allocated during this function, we no longer need. So that's kind of a neat trick. And let me make sure that I'm doing that, because I don't think I am right now. Okay, QuackBX wants to know, how did you get into the Jai beta? I emailed, I think the email's like language@tekla.com or something. But yeah, it's basically the folks that are developing it at Tekla, that's THEKLA, have like an email set up for communicating with people who are using the language and who want to use the language. So yeah, I emailed them, and yeah, they emailed me back and said, cool, here's the beta, try it out, let us know if you find bugs, and so on and so forth. Yeah, and there's a little bit of an online community as well. There's a GitHub wiki that has some nice information. So yeah, if you're curious about the language as a whole, definitely check that out. I'll see if I can find a link to it in a minute. But before I do that, let me fix how I'm using this temporary storage here. I thought this was Jonathan Blow's language. Yeah, he's the main guy at Tekla. So yeah, a lot of this code, or a lot of the code in the compiler he wrote, I would imagine, I don't really know, but I would imagine he wrote a lot of it. But there is a little organization that's working on it. I think that it's also the same organization that works on the games that they make. Yeah, this is kind of a neat thing that maybe I should go into at some point. How do I reset the temporary storage? Oh, here we go. Reset temporary storage. That's what I need to do. So that should happen at the end of this block, probably. Well, the problem is when do we return? Right now, we don't return anywhere else, but I'm going to do this just in case. Basically, this defer means do this at the end of scope. So it's kind of like in C++, we have RIAA. I think that's how it's spelled, RAII, I forget. And yeah, it's kind of interesting because in my opinion, RAII is cool, but it kind of conflates resource management and wanting to do something at the end of a scope, which are related, but not exactly the same thing. And so in Jai, I like that it's kind of separated, where defer is, hey, I want to do this at the end of scope, and resource management is handled elsewhere. Yeah, I wonder too if I can run this in a debugger and see what happens. I know I was able to do that on Windows, but yeah, I don't know if it'll work on Mac at the moment, or maybe I need to do some extra setup. But let's try it. Yeah, so maybe we can look and see inside the allocator what's actually happening when we do this. That would be cool. RAII is probably the worst acronym in C++. I would disagree. SFNA is the worst acronym in C++. Both are bad though. Yeah, neither one is especially pleasant to work with one way or another. Cool. I'm also going to set the smoothing time to be something reasonable, just so that we don't have to wait half an hour every time we change the gain. Let's see, smoothing time and prepare. Actually, I'm gonna fix this also. Here, and we'll make it 0.05 maybe. That's a reasonable smoothing time. All right. Yeah, I should probably make like a dedicated function to do decimal conversions, but I don't feel like doing that right now, so I won't. Yeah, let's see if we can debug this program, see what happens. Let's do this. I don't know if this is going to work at all. Are there official cloud bindings for Jai, or did you write them yourself? I wrote them myself. They're probably not complete because of that. But yeah, if anyone else is using Jai and cares about clap stuff, yeah, feel free to add to them. There's also, I didn't know this when I started writing it, but there's a bindings generator that Jai has available. So I probably should have used that instead of writing it by hand. It would have saved me like a whole day basically. But yeah, these are the bindings. So it's no, let's do a simpler one maybe. Yeah, it's actually very straightforward. So this is like the Jai version, and then the C version is almost identical. Where is it? Stream. And there's been some updates to clap also since I did the bindings. So I should probably go through and do an update as well. But yeah, so this is the C header for a clap stream. And then this is the Jai version. So it's nearly identical. Really easy to kind of go back and forth. There's just kind of a lot of things you have to pay close attention to, like, oh, do my return types match up? Do my names match up? Things like that. So yeah, once I figured it out, it wasn't too hard, but it probably could have been much faster if I'd used the bindings generator. So yeah, maybe I'll take a day at some point and see if see if I can get that to work. All right, so let's try debugging. Oops, don't do that. So let's see. Yeah, let's see if we can set a breakpoint there. No? I guess it doesn't want to let us put a breakpoint there. Interesting. Fascinating. Okay. Either way, let's see if we can attach to Bitwig. All right, looks like we're in Bitwig land now. Is that gonna work? No, maybe. Yeah, so we're probably not going to see anything on the main thread since I don't have a UI implemented. Maybe I need to tell CLine to pretend that this is a C++ file. How do I do that? Languages and frameworks, C++. Maybe you could try using LLDB directly. The compiler should have generated a symbols file. Yeah, it did. Where is it? At least I think it did. I'm not super familiar with how like dynamic library stuff works on Mac, but my understanding is that this like .dsym has some symbols that are helpful for debugging. So yeah, one way or another, it should be possible. So the nice thing on Windows is that I was just able to open up Visual Studio and it found everything very easily. Yeah, I'm not surprised that things are maybe a little bit more not set up yet on Mac, especially since this is the first version of the compiler I've tried that even works on Mac at all. So yeah, I'd imagine maybe there's some stuff to do to get this to work. Let's see, attach to process. I haven't used LLDB plain in quite a while. Actually, I wonder if I can even just do it from VS Code. Debug. I feel like this might get very cumbersome very soon. No, okay. Yeah. All right. Yeah, and I feel like the other problem with LLDB is that it'll be harder to look at the stuff that I'm actually looking for because I don't know ahead of time what some of the names are. Let's see. Yeah, let's see. I want to attach to a process. How do I do that with LLDB? Attaching with LLDB. Maybe this will help me. LLDB-N. Okay, let's try that. We'll exit C-line for now. Actually, let me try one more thing before I quit on C-line. I just need to see if I can get it to view this file as a C++ file. Extensions, file type. Okay, editor and file types. File types, C++. So we'll pretend that Jai is C++. And maybe, hey, there we go. Okay, that was actually pretty easy once I knew what to do. So maybe next time we'll try LLDB for better or for worse. All right, so it's not exactly showing me the context at the moment. Let's see. So I've got my clap plugin T. Let's see. Yeah, I would hope to see, I would hope I could see self, but I may not be able to. Plugin data. Can I cast it or something? I don't know. And I can also do LLDB within here, maybe context. LLDB print variable or print Stretch maybe. And you can apparently just also use Xcode. I imagine that would work for Jai too. Yeah, I think it does. And it's working pretty nicely in CLine, except that I'm not able to see all of the things that I would hope to see. I wonder if, yeah, so if I do, if I create a variable, then that shows up here, no problem. At least for variable types that it recognizes, maybe. Oh no, it seems okay, yeah. Yeah, okay, so we've got our events, everything seems fine there. Yeah, it's just not showing me the context, which is a little bit annoying. I wonder if I go through a function, what it's going to show me. Oh, interesting. So when I look at this in Visual Studio, it shows me the context as if it were another argument to this function. So yeah, maybe there's some extra things that I would need to figure out to be able to do that. But yeah, let me see if I can print. Let me see if I can print something with LLDB name variable context. No variable named context. Interesting. What about here? No. P variable, yeah. Very rusty on my LLDB. There we go. Multiple internal symbols found for context. Yeah, that makes sense, I guess. What if I look for audio thread context? Declared identifier, interesting. Yeah. What if I do self? Okay, so it shows me self. Now, what if I do self audio thread context? Oh yes, I did need to use a pointer. So one of the nice things about Jai, or I guess I don't know, could be good or bad depending on how you feel about it, but it uses dot for both accessing a member through a pointer or through a regular object. So you don't have to go back and forth between dots and pointers. Sorry, dots and arrows. Pros and cons, I guess. Con here was that I forgot I needed to use an arrow. So SVF plugin. So basically, I can do this, but I need to go through an inheritance tree. Is going to be the trick. So SVF plugin is going to be a audio processor. And that gets worked out somewhere in here, if I remember right. Here, SVF plugin. Okay, it should have an audio thread context. What if we look for the base? There we go. All right, that's interesting. All right, so we've got our base. It's got all this stuff in it. And that's a base is plugin base. So that comes from here. And where does where does the process get called? You can get extension. Maybe that gets called here just straight up. Yeah, sorry if this is incredibly boring, by the way. I'm still trying to figure out my way around using Jai on Mac OS. Yeah, it's kind of a new experience for me. So self is SVF plugin, right? Oh, let's see. What do we get at the top here? So this is plugin base. All right, temporary storage, yada yada. Plugin internal. And there's a bunch of function pointers. Interesting. Yeah, this might be a little tricky to figure out here. Base audio red. Oh, you know, I might have spelled some things wrong. That is totally possible also. Hey, there we go. Yeah, I was just spelling it wrong. Yeah, so basically, if we look here in our context, we should be able to find some information on our allocator. Allocator. No, is that not the name of it? Audio thread context. Oh, we can just use a temp storage. That'll be easier. Is not a pointer. Audio thread context is not a pointer. Do we need to use dot? That's odd. It worked correctly last time. Oh. Here we go. Yeah, here's our temp storage. Does it do tab expansion? Let's find out next time. Good question. Yeah, so here's our temporary storage. Interesting. Okay, it fixed it for me and put the dot instead of the arrow. Interesting. Interesting. Why is it showing up as having no data? That seems like a mistake since the temporary storage should be set here. Well, actually, I guess I don't set it there. I guess I just set it here. No, it gets set here. Yeah, that makes sense. Okay. You know what? Let's just try opening a new plugin instance and seeing what happens. See if we hit the breakpoints we expect to hit. There we go. Okay, init audio thread context. Let's see. What do we get here? We don't get much. Okay. Let's see if tab to complete works. It does not. All right. That's fine. Okay, so we've got our audio thread context. Is this a pointer? I think it is. Audio thread context. Oh, self is an audio thread context. So let's print what's in temp storage. There we go. Yeah, so now we've got our data, which we just set. And then if we go through here and print it again, we should see our size is 8192. So that's basically what temporary storage is. It's just a block of data. Nothing particularly special, but then we can use it as an allocator or we can use that memory to allocate temporary memory and then reset basically a stack pointer to go back to something else later. Or sorry, to go back to the beginning of the data later. Is it like a PMR allocator in C++? It is, but, and this is what I talked about at the way beginning, so probably a lot of people weren't there, but the nice thing is that I have this context, basically. I have this context scope here. And the neat thing about it is that anything in this scope that wants to allocate memory will use the context allocator. So if I call some third-party code that uses pretty much any dynamic memory allocation, it's going to use the allocator that I set here. That's really hard to do with PMR, at least as far as I've seen so far, just because it's really hard to figure out a way to get third-party code to use the allocator that you want it to use. Again, that's just my experience. If people know some tricks, then I would happily learn them. But yeah, there's also, you can kind of see here, there's this overflow allocator. So if my temporary storage runs out of memory, it will go back to this default allocator. And maybe I want to change the overflow allocator to be something that is more likely to be real-time safe, since I imagine the default allocator probably isn't. And that's fine, Yeah, that's just something to maybe check later. But yeah, I do want to see if I can, what happens when we reset the temporary storage. I wonder if I can put a breakpoint in there and see when that gets hit. Here we go. Okay. So this is getting called from the defer statement in our plugin process. So this is happening at the bottom of the scope, but I guess it finds it here because that's where the defer statement is. So I think C++ allocators are not very ergonomic at all. I was watching the Zach Line, maybe I pronounced that wrong, episode of the ADSP podcast, and he was advocating to remove allocators completely from the language. Yeah, I've heard that from a few people. I don't really have a opinion on it very much. Personally, I don't really use allocators at all in my own work. I just stick with either I use a vector and I allocate the memory ahead of time, or I use something like an array where I don't need to worry about allocation. But yeah, I know for people who have worked with allocators, they can be a bit they can be a bit challenging, let's say. No member named temporary store. That's because I spelled it wrong. No member named temporary storage. Maybe there's a base. There we go. Can I dereference a pointer? Hey, all right. That's cool. Interesting. So when I'm resetting the temporary storage here, I'm actually not using the temporary storage that I thought I was. Probably what I need to do is also change the context dot temporary storage to be my, well, let me think this for a second. So here, I'm trying to set my temporary storage in the context to be that. Seems like that should have done it, right? But the problem is when we were looking at the debugger, we were saying that the temporary storage size was 1024, and we're expecting it to be 8192. So where did we go wrong here? Yeah, I feel like I'm not fully using this correctly, but that's okay. It'll get worked out. Context.allocator equals temp. Where do we define temp? Temp equals allocator, temporary allocator proc. That's somewhere. Where is it? Temporary allocator proc. Here we go. So temp equals allocator, temporary allocator proc null. What am I doing wrong here? So I need to define my own allocator basically using temporary storage. So context.temporary storage should be there. You know what? Let's set another breakpoint and see where that gets us. This will be curious to say the least. All right, so here we go. Plugin process, create process buffers, and we're allocating here. That's what we like to see. That's some good news. All right, so we're using the context temporary storage. Text temporary storage. I'm doing this wrong again, aren't I? There we go. All right, so temporary storage here appears to be null. That's not great. Oh, that's because it hadn't been set yet. Is that correct? No, it seems like it's something. All right. If size is greater than current page bytes occupied. I feel like I am doing something wrong here, but I'm not 100% sure what. If not success, return null. Okay, so it did succeed. That's good news. Yeah, but I'm very curious why that is showing up as null, right? Let's try this. Oh, okay, so we do have some temporary storage. It's just really small. Weird. Okay, something's strange here. Am I pushing any other contexts in between this push context and where this reallocation is getting called? No, because I'm doing that there. Yeah, okay. I think I'm doing something wrong here, but let's do some tweaking and see what happens. So I have this temp allocator, which is happening there. And so I guess I need to create a new allocator. Create a new allocator here. All right, so we have allocator proc and we have data. All right. And when we're creating our temporary, or when we're creating the global temporary allocator here, we're using this temp kind of thing. Okay, that's fine. I think that all makes sense. It's using the temporary storage that's in the context here. It seems like the temporary storage is the wrong thing, maybe. Let's try this. Context.temporary storage equals audio thread context.temp storage. I thought we had already done that, but maybe I was wrong. Yeah, okay, that's not correct. It wants a pointer. Let's try that. All right, and let's see if it crashes right away. It's not. All right, that's good news. Cool. And let's see. Yeah, let's see what happens when we go to allocate memory now. So if we see what's in TS. Interesting. So right now it's showing data is 0 and size is 0. But then I guess it's going to add a new page, so then it's not going to be 0 anymore, which is a little bit, I mean, I guess that makes sense, right? Let's go back to reset temporary storage and see what happens there. So now we've got this 1024 situation. You know what probably did wrong here is when I init the audio thread context, I give it this temporary storage, but I don't think I'm working with it correctly. I imagine that probably gets overwritten somewhere else. Yeah, this is a tricky one. Yeah, I probably need to just dig into this a little bit more. I wonder if this original data and original size have something to do with it. No, I feel like, well, you know what, let me see something else here. What happens in add new page? Okay. So now we're using the allocator, which in this case is the overflow allocator. Right. Interesting. So it seems like I'm not doing the context allocator thing correctly. Let's see if I can improve on that here. So let's see, temporary store context. Allocator. All right, so we want to do our own allocator. Allocator example, allocator proc. Interesting. So how do I use temporary storage as an allocator? I think that's what I'm doing wrong here. Reset storage, memory debugger. Okay. So here's all the temporary allocator stuff. So yeah, basically I want to replace the temporary storage with something. Let's see. Let's see. Result.allocator equals 10. All right, so that's basically what I'm trying to do here. Is set the context.allocator to be temp. But then I also need to make sure that the context temporary storage is what I expect it to be. But it doesn't seem like it's working quite right. And I'm not totally sure why. Am I still attached to anything? I think I'm probably not. Let's try this again. Anyway, yeah, sorry for getting maybe a little bit too far into the weeds here on some of this allocation stuff, but I find it interesting. So hopefully some other folks do as well. Audio thread context. Unless I spelled that wrong, right? No, that seems right. Okay, weird. Oh, it's self dot audio thread context. Temporary storage is not what we expect it to be, but whatever. Allocator is temporary allocator proc. That's good. That's what we want it to be. Temporary storage is that. Yeah, so another nice thing is that we could override the logger to maybe try to do something that's real-time safe there. But that's real-time safe logging is hard, so maybe not today. Temporary storage. Yes, I didn't mean to do that. No. So this is a pointer. This is not a pointer. Maybe it's that. Oh, I see. Okay, so temporary storage. No, there's definitely something named temporary storage in there. Okay, it's temp storage. Interesting. So this seems to be a different size than we had tried to set it to when we did all this stuff here, right? Yeah, that's what we should be working with for our context temporary storage size. Weird. All right. Yeah, I feel like I'm making this overcomplicated for myself. There's definitely an easier way to do what I'm trying to do here. But yeah, it's not it's just not doing what I want it to do. Maybe I should just write my own allocator instead of trying to use temporary storage for everything. That might be the way to go. Yeah. Yeah, you know what? Let's do that. Let's write our own allocator. So we're going to do something very simple here since don't have a ton more time. So this will be audio thread allocator. Right, and for this, we need to follow the JAI sort of guidelines for how an allocator is supposed to work. So let's do that. Here we go, allocators. We've got an allocator processor, which is basically this. And let's see how we want this to work. So we've got an allocator mode. We've got these size things. And then we want to return a void pointer. Yeah, so let's see how this gets used elsewhere. Interesting. I don't know that I want to override all of these or handle all of these modes. So maybe I'll try to do something a little simpler than that. Let's see if we can just do what the temporary allocator is doing, but with some simplifications. All right, so let's see. Allocator data in this case is going to be our temporary storage from there. Yeah, you know what? I'm not sure I want to get into this today. This might be a bit too ambitious given how late it's gotten. Yeah, maybe this is a good thing for next time or however we want to do it. Yeah, I'm just going to take one more stab at getting the existing temporary storage to work for me. And yeah, let's see if we can get that to work. So let's see, plugin process context. So context.allocator equals temp. That's what we want. But then temporary storage. So let's go back to here for a second. When we're in here, we want to look at temporary storage and then go through and deal with stuff here. So where does add new page happen? Add new page happens here. This is if size is greater than the amount of size left. So we don't want to be hitting that unless we really have issues, right? Interesting. Temporary storage. Because temp is just a regular allocator. Yeah, I think maybe I'm overcomplicating my life here. I think I could probably just use it as is. It just wouldn't, like I could just use context.allocator equals temp. And I think that would just work. The issue I would run into is that it would not be as much memory as I would want. But at the end of the day, that's not that bad. So then the question is just, if I want to make that be more, if I want to make that memory be larger, how would I do that? So let's see if we can find another place where temporary storage gets created. I want to match case. So this is a place where we do it. Okay, so we have a new context here. Oh, I see. That happens before we do a push context. That's probably where I'm messing up here. So we want to set that stuff first and then do push context after. So let's do this. Actually, maybe I don't even need that. Let's find out. Oh, I didn't finish deleting my abandoned experiment. All right, let's try that. All right, so where do we want to put our breakpoints now? Maybe here. Might have some old breakpoints lying around as well. Okay, so let's see, after we define TS, okay. Something's being weird here. Maybe that's all right. We've got our context. Context has a bunch of stuff in it. Context has an allocator, which is our temporary allocator. It has temporary storage, which is there. Let's see, context dot temporary storage. See, I don't believe you. Context dot base dot temporary storage. You reference that. Okay, so it seems to think that it has 0 temporary storage. That doesn't seem correct to me. Okay, we're gonna have this this issue. Yeah, the other thing I'm wondering is if I should just be doing what they do here, where they create a new context and just live with that. My concern is that I don't know I don't know what kind of overhead is associated with creating a context. Maybe we can find that out. Well, really, the overhead would be whatever is in a context base, right? So, yeah, basically we've got some pointers. We've got this dynamic entry that is, it's an array. It's not, hopefully it's not too large. I don't know how big dynamic context entry is. And maybe they're going to get rid of it later anyway, so it's probably safe. These are basically function pointers, some small values, I guess, probably some more function pointers. All right, I would guess that it's safe to create this in a real-time function. That's my guess. So let's do it. Let's just see what happens here. So what I'm gonna do is I'm gonna get rid of that stuff because we no longer need it. And instead, I'm going to do this. So this will be I'll call it new context just to avoid naming confusion. Context, new context. Yeah, if only I could spell. Oh, I lost my example. Next temporary. Here it is. Okay, yeah. So we can even allocate this on the stack just up front. You know what? Let's do that. Just make our lives as simple as possible here. I do think this will help simplify things. So we want this to be 8192. We'll make a new temporary storage as such. And then when we do our push context here, we'll push context. I'm just going to call this audio read. You know what? I'm going to call this real-time context. Push context, real-time context, and see how that goes. Not happy about something, real-time context, right? All right, let's give that a try. All right, let's see what happens. Reset temporary storage. Okay, let's ignore that for now. Oh, interesting. Where is? Oh, we didn't set the allocator, right? So we want real-time context allocator equals temporary allocator. Spread that. There we go. That's about what we expected to see. Now let's see what's in temporary storage. There we go, 8192. Yeah, that's looking good. Cool. So yeah, this is working. It's maybe a bit more I don't know. It took me a little longer to wrap my head around than I expected, but it's also simpler than I had been planning. So that's nice. Yeah, the other thing that I had meant to do that I'm not going to get to today would be to mess with checking how much of the temporary storage gets used. So if we try to over allocate more memory than we have available, then we could have some way of handling it, or at least checking for it at compile time. But you know, not going to get to that today. It's a little too late for that now. But yeah, thanks for watching, everyone who stuck around. I know it was kind of a long and probably at times a bit boring live stream, but yeah, hopefully you guys enjoyed it and maybe found some inspiration here. Yeah, I know for me, I've been thinking about ways to get something like the context that Jai has available that I could use in my C++ code. Obviously, the disadvantage would be that it wouldn't work for with third-party libraries, which the Jai version would, but that's okay. We can deal with that in some other way in C++, or maybe someday I'll be writing Jai code full time. Who knows? But yeah, thanks for tuning in, and you guys all are enjoying your Monday. And yeah, I'll probably be back in maybe next week, maybe the week after. And we'll be going back to the multi-tool plugin that I was working on and making some progress with that. I'm pretty excited about that as well. So, all right, see you guys later.